on the Theranos point you just made. I read Bad Blood, and it doesn't, in my opinion. So I'm just kind of curious what you think on this subject. Were they ever on a pathway to getting anywhere close to what their mission was? Because from what I understand, they were even like using normal blood sampling technology and like masking it. From what I understand, they weren't even really developing like R&D to like make what they were trying to make, which also was a problem. Like, so do you think if the funding continued and they didn't, start messing with humans at all, because they were kind of freaking people out, do you have cancer? Do you not have cancer? Do you think eventually they would have met it? Do you think they would have like achieved their mission?
I don't know that that team ever could have been successful because integrity around data is central to
Mm-hmm.
scientific progress. But I will tell you one little interesting anecdote. Our chief technology officer, who's a physicist, PhD in physical chemistry, which is the overlap between physics and chemistry, just what we need, for our actual nanot engineering, actual nanot design. When Theranos first announced their test with their little nano container and all the tests that they would run, um, our CTO said that's bullshit. And and the reason he knew it was bullshit is that you need a certain when you have a given blood volume and you're running multiple tests on that blood volume, and we have to do this too. You need a certain concentration of target in that blood volume to have statistical validity, statistical significance. I'll give you one example. So, say you have a blood volume where you literally only have one molecule of your target, and then you have another blood volume where you have three molecules of your target. Well, your test would tend to indicate that sample B had three times the concentration of sample A. But in a volume that small, a variation between one molecule and three molecules is not statistically significant. That could easily be just random that happens. If you had a much larger volume for a molecular species that rare, a molecular target that rare, you would see that the difference between sample A and sample B, let's say the samples are 100 times larger, you would see that you have 1,100 molecules in sample A and 900 molecules in sample B, or probably it'd be more like orders of magnitude more than that. But it could actually be the reverse of what you saw when you only had one molecule and three molecules present. But it would be statistically more valuable, more reliable, because you have a larger sample and a larger set of molecules. So the variations between them are going to reflect better what's going on in the whole organism. Okay.
Mm-hmm.
Well, he just crunched the numbers off the top of his head and said this is bullshit because the number of tests they're doing in a sample size that small, there aren't enough of the target molecules to create statistical validity. So, of course, that's something we have to think about a lot. Anytime we're quantifying a target for treating disease, we need a certain volume size, certain sample size, in order to know what we're doing.
Mm-hmm.
So, I guess to
Uh,
answer your question, a different team that was more honest and understood the physics and was more transparent about the physics could have made a pretty good product that tested. It didn't have to be that number. How many tests were they doing again? I can't remember. It was over
it was a
100.
lot. Yeah, it
It
was a
was over
lot.
100. Um, the systems that are out there that are really reliable, like there's a company called Biotechny that has a microwave sized device called the Ella, ELLA, which is really cool. And it uses a microfluidic chip and it uses a relatively small blood sample, but it only does 8 tests. Um, and the specific tests that it offers, you can get different chips with different tests, but the specific tests that it offers have been chosen because a blood sample, or can use, I think, urine and saliva as well, a blood sample of the volume they're specifying be used in this chip will actually give a reliable, statistically valid concentration of that target in a
Mm-hmm.
given patient. So the biophysics were wrong from the beginning, and she was trying to she had a concept in mind, and she was going to ride roughshod over any objections, unfortunately, including science and physics.
Check out the full video now and subscribe. It's free.